Hi, it's Gadget UK here again, back with another C64. I bet you're getting sick of seeing these. I was going to say I am, but I'm not really. Yeah, it's a C64C, and actually it's a C64E. It's the version with the separate colour RAM, so yeah, it's kind of like a desirable, slightly more desirable than the later one that's got the colour RAM built in. But anyway, they're dead reliable, those Sharp chips. I don't think I've ever seen one of those fail, so yeah, it's the same old story, components bent over. So I'll just straighten one or two of these up while I waffle. So yeah, you can see it's got a number of chips missing here. That's the VIC, or it would be. That is SID, clock gen chip. CIA CPU. But I've got those chips from one of these boards that I salvaged the chips from ages ago. I might post a link down below. It was one where there was horrendous damage around here. Someone had used like a, I don't know, a 50-watt iron or something and like disintegrated the pads. Are just like, it was like charcoal on the underside, and then like ripped them all off on the top side as well when we lifted the chip off. So yeah, this board isn't in too bad condition, but you can see some delamination. Someone's used hot air to remove the chips and it's a bit swollen sort of around there, just a little bit. He is not too bad. Pads look alright. Someone's obviously had a go at swapping the RAM, so maybe there is still a fault on this board. But it could have been one of the CIAs that someone took off this. I don't know, that could be what the issue was. Or maybe a dead CPU or a dead VIC. Maybe even a dead SID. But anyway, you'd expect that because that's socketed. It's pretty easy to test that. If you get a dead C64, first thing you should do is remove the SID because it's always socketed. There may be an example out there where it was soldered on, but 99 times out of 100 it's socketed. Yeah. Anyway, I've done a quick straighten up of whatever I need to do here. I'm going to literally just fast forward through the start of this video here. Again, a little bit of delamination here. Can you see it looks a bit swelled in the middle here? Just ever so slightly. So yeah, what I'm going to be doing is using the fiberglass brush on any oxidized connections, clean up with IPA and cotton buds, unblocking all the holes, clean up with IPA and cotton buds, and just getting some sockets on. We need a 40-pin dip there, 40-pin dip there, and a 40-pin dip there. I'm just going to stick something under there so that the board doesn't just press onto the mat, because obviously the heat will transfer through to the underside. Now clean with some IPA. I've cleaned pretty thoroughly there because one or two of those I had to heat, extensively. That looks pretty clean. Bear in mind it's probably a bit delaminated from hot air removal originally. Anyway, I can get a socket back on. I have inspected the wires and things. There's no damage around there really, other than just a little bit of delamination. So if you apply a bit of logical thinking here, it's perhaps better to fit the CPU socket first, because if we do that, you can get a CPU and a VIC and some RAM and test it, because you don't need the CIAs. But I'm going to get this board working no matter what lengths I have to go to. Yeah, there's a little bit of delamination, but hardly anything. When it's got sockets on it, you'll never be able to tell. So yeah, I'm going to go right to, let's say, a conclusion with this. It will be fixed. There are very few things that I've not been able to fix. You can generally fix any, well, you can always fix every single thing. It's just a question of how much time you want to invest. Yeah, the only hole that I can see is slightly narrower here is this bottom one here, so I'm just going to press and turn with the dowel just slightly, so it's not like I've made it go a strange shape or anything or damaged it. Well, it is now. There we go. Yeah, so it was just a little bit stiff. And when the stiff going in like that, I do inspect to make sure that it's not pushed any of them out of the edge here, because they can raise. Yeah, those look fine, I think. So it's incredible how much more productive I am now I'm in this new environment. Not only is the lighting better, now I'm used to it, but just having everything to hand and everything on the table here, yeah, it's just way quicker. So I'm going to clean up as I go along on this one. I'm going to clean up around that CIA in a minute. But yeah, the solder here is just crazy, copious amounts of solder. So I'm just going to like literally bob into each pin here. We're assuming that there was no damage when someone fitted these sockets. But I mean, I can do connectivity. So So I added some dedicated flux there. You can see it's really gooey around here now. I'm not sure those look much better, to be honest. They might do when it's toothbrushed. Now we'll clean the whole board later, but I just want to focus on the bits that I'm dealing with at this present time. As you can see, that's not too bad at all around the RAM now. Yeah, so you can still see the bit of delamination, can you see that as I rotate it? Just in the middle, that's what happens. So I may need to reflow these wires here. But anyway, you can see it's nice and clean, and the RAM is nice and clean there as well. Kind of almost looks factory. If we flip it over, this socket obviously is okay now, and yeah, the RAM sockets look pretty good there, the dual wipes, so those will be alright. So the next thing I'm going to do is get this on, because then we can test it, can't we? I'll deal with this CAA socket later, and there's a wire on block there, but and again, I can feel it delaminated. So that's where, you know, the top pad could have pulled away from the through hole, and you can have a problem. That happened on one of the previous boards, and I can press that, I can feel it's just slightly warped, not a lot. Anyway, you won't be able to tell. Some of these caps could have been affected by the excess heat there as well. So I've unblocked all the holes there. There's something I've never seen before. This resistor is going into one of the legs of the CPU socket. So that is really weird. Like, how did the CPU socket connect to it? Was it over the top? I don't really know how that would have been joined up. So I need to go have a look at some photos and compare to my other one or two 64C boards I've got here. I mean, technically it's an E, isn't it? It's got the label for the E, but I don't remember seeing that. It's a very strange modification. You know, that resistor looks like it's supposed to go up here. Has it come out and someone shoved it in there? I don't know. It's not supposed to be there. Now, rotating it around, you can see it's like twisting the leg here. It's almost like both the solder points were molten. Maybe it's just about hot air, you know, someone's had it slide around to that point and then it's settled into that hole. I don't know. But that does seem to be the case. So yeah, I'm just going to put it back where it should be. Yeah, I'll just measure that through to the other side to make sure it's soldered all the way through. So things are progressing quite nicely. We've got a socket there. We're now onto this socket. But closer inspection, look, something missing there. Something missing there. Another wire to block levers in the middle as well. Looks horrible. So I'll fill that, just make sure there's connectivity from both sides, because again it's delaminated. You can see it looks a bit, you know, it's light green here. That is the clue. You see a colour difference, but also it's a little bit warped ever so slightly. But anyway, these inductors, well, actually I was casting my mind back to the bread bin that I decommissioned years ago, and look, I happened to take them off it. So yeah, I think I need to test these on the, or just look at the part designation, just to make sure they're the same size, because they may be different. I may need to just check the schematics here. Let me just have a look at them, I'll tell you what they say. Yeah, so they say 04 Tokin. They both say 04, the manufacturer's Tokin. And there is no other marking on them, so I am guessing these are going to be the same size as each other. And you can generally tell that if you were to count, you know, inspect them with magnification and look at the number of windings. They're identical. It's the same gauge wire, the same number of turns. So yeah, they're the same. So we just need to fit one there and one there. So yeah, I'm pleased. I'm pleased we've got those. It's amazing they have come in use. I will do some tests for shorts and things before we power this on, and I'll power it on without any of these chips socketed, actually, just to make sure the supply rails are okay. Anyway, I'll get those in next. I'm just pressing upwards from the other side. Let's just try and solder at one point. Just let go a sec, and then I'll try and hold it nice and straight and flat. That's it. And solder that side. Yeah, that's pretty straight there, so that's one down. So both the inductors here are fitted. I've cleaned from the underside this time. I did just block that wire, but I'm going to solder it from this side as well, because the one, well, the one next to it looks a little bit like there's a gap there. I'll just test connectivity. I reflowed both of those wires there, and they're both connecting through to the other side. Socket is nice and straight, so let's just commit to soldering this on. I'll clean up afterwards, I think. But let's now go see what's going on with the power rails and stuff. So let's rule the basic stuff out before we even attempt to power this on. We'll get some contact cleaner into the socket there. Oh, be careful not to knock down here. All around the power switch. I will have a clean around that afterwards because it's pretty dirty. I'm going to connect the LED up first here. Let's just see if this is the right way around. And I'm just going to plug the power in, switch it off and switch it on. Nothing there. Let's just try this the other way. There we go. So you can see got power LED. So I'm going to measure from ground there to one of the pins on the 5V rail. 5.19 volts, you can see there. Let's just check that one. Yeah, so we've got 5.19 volts. Now we've got the SID socket down here. We need 9 volts on this board as well, so let's just see if we can measure the 9 volts from the ground below. I'm measuring from the ground around the crystal there, trying not to block the meter. And let's just check up there. There you go, 9.24 volts, so the 9 volts is there as well. Right, got a few chips here. We've got an 8500. That was the newer version of the CPU. There is a little bit of solder on there, so I think actually I'm just going to go over this with some braid and remove all the bits of solder, so I'll do that in a minute. An 8565R2, I believe that was the newer VIC. I need to go check that, make sure that's not an Amiga part. I don't think it is there. I think they're a bit larger, the Denises and stuff, aren't they? It's like 48 pin, is it? 44 pin. Got a clock chip, we can get that in. That's got brand new clean legs, so let's do that first of all. Pin 1 is up here. So I'll just squeeze that in, I think. There we go. So we've got our clock gen IC. I will stick this in, I think. I'm just wondering why these are here for this here. That isn't that the CIA? I believe the VIC goes here. I will just confirm that before I power this on. Yeah, so there's our VIC. The CPU goes up here. I think actually the only thing I need to do with this CPU is, because I think I removed the solder previously, it's just make sure the pins are straight and there's no bits of solder to catch. I mean, there's no point in having sort of spare ICs out. I mean, if this board stays in my collection, I can always just remove a chip from a socket in order to test the board where, you know, if I run out of these. Because this is the thing, this is like my last C64 CPU. CPUs I've got literally none of. In fact, I've got very little of any spares left. All of the spares I had have been used in this series here. So let's get the CPU into there. It's got short legs, so yeah, it went in really well that though. So that's the CPU in. I'm not going to stick the CIAs in at this stage. So we'll connect the video here and connect the TV up, and let's just see if that's doing anything. You watch, it's going to work, isn't it? There's going to be nothing wrong with it. Alright, so we're on the correct channel now. Let's just switch it on, just feeling the VIC and the CPU here. Nada. That's interesting. So, oh hang on, there's no RAM. There's no RAM, I knew there was something. Yeah, we're not going to get very far without any RAM, are we? This is the stuff I showed in the C16 video. Actually, it's like, I don't know, it's got an eye on it. Is it Intel? I don't think it is. It doesn't look like the eye from Intel. It's obviously another manufacturer. But anyway, we've got 2 of those. Wrist I really should have on. And I did test these chips previously, so these should be good known working RAM. 32K each, 4-bit. Hence, you get 8-bit at 64K with 2 of them. There we go. So that's the RAM in. Again, I'm just going to have a feel of these chips here, switch it on. Yeah, nothing at all, strangely enough. Let's switch it on again. I've done all the sanity checks I can think of here. Everything is okay, you know, everything's connected up correctly, the chips are in the right sockets. The chips, to my knowledge, are good. So, yeah, I've got the dead test. Let's just see. Make sure the power's on. Yeah, make sure it's doing something, and then I'll start checking clocks and things in the data bus maybe if this is it's not booting. So the cart is in, switch it on, and you point it at the TV, and it's doing nothing. Nothing at all. Maybe it's a clock problem with this, maybe just the crystal's balked or something. I did come across one of these before where the crystal was dead. But of course there were so many things, you know, the sockets had been, you know, chips had been removed on this. It could be a bad wire somewhere, it could be some clock or something not getting somewhere or something like that. But anyway, the dead test is not dead testing. I'm feeling the tops of the chips. Just like very lukewarm as things warm up here. Yeah, so we're powered on again. You can see the meter there. Let's just check again up here. 5-volt rail's good. The SID is up there, 9 volts. So yeah, we've got no power problems or anything here, but it just isn't doing anything at all. So I'm just going to scope around the CPU. Yeah, we're getting something down the pin 39, I think it is. Some crazy signals there. What is going on here? Just checking the main crystal here. Yeah, that's oscillating. 17 point whatever, that's correct. I need to get the pin out of the CPU next, but if we look at pin say 39, we're getting a signal there, hang on. Yeah, pin 39 of the CPU, 0.98, so that's correct. It's set into PAL certainly. Pin 1, hang on. Pin 2, pin 3, pin 4. So yeah, levels look a bit strange. Yeah, so we are getting some strange shape to some of the signals here, without a doubt. Anyway, I need to just check the clock, so let me just have a look at the pin out. Right, at this stage, I think actually I'm going to remove the combined ROM here. So as far as I understand, this is the character ROM, I think, and this is the kernel basic merged. So instead of having two separate chips like this size, they merged them together by the time you got to C64C. I mean, there could be a PLA fault, it could be a bad connection somewhere, I don't know. It's what we do know is the clock in pin 1 here is there, 0.98, and a clock out is there. Yeah, we're not getting anything, any signs of activity. The dead test is not dead testing. So, no CIAs on here, SID's not on here, there's nothing could be conflicting. The only things that could be an issue is, obviously we've got a few 7.4 series. The color RAM ain't going to cause this problem. Another 7.4 series I think up here. I think one of these may be a 4066 actually, if memory serves, but anyway. I think I'm going to remove that, just to pull it off the data bus, just to make sure that BASIC and the kernel can't possibly clash with the ROM, because if the PLA logic there to do with switching that is okay, and the other address decoding and stuff, because it provides the 257s here for this as well, you know, the muxin. Yeah, I think we just remove that, and then it's kind of like a bit of a level playing field. The only it narrows down the possibilities to, is there something here or is it a bad connection somewhere. I guess the one positive thing is it hasn't just been a reassembly job, has it? Because then it would be super uninteresting. And obviously if this does spring back to life after removing the ROM here, we can then investigate further. And I could do that now, you know, I could be scoping the data bits and stuff and go, I've got a stuck data bit somewhere or something like that. And that's probably what is going on with this, if there is a problem. But we'll be able to work that out, measure that after the event by you know, socketing this up and putting the chip back in there. The desolder port needs a bit of lubrication actually, it's not sucking very fast. Yeah, I have to get a little bit of WD-40 in there. It's sucking super fast now. Right, let's just have a this side I think has come off easier than this one, because on this side it didn't push inwards, and this one I've pushed inwards, and they've pushed away from the edge. This one here, I'm not so sure. There's barely any pins protruding there to grip, unless it's coming through on its own. I don't think so. Let's just flip it over and inspect. Yeah, inspecting from that side. There's still a fair bit of solder on that side, as you can see. Yeah, there's still a fair bit of solder on that side, I think. I'm going to use hot air to remove this actually. It's been subjected to hot air already. You know, we've got a little bit of delamination and we'll zoom you out a little bit. So yeah, we've nothing really lost here, but the pins are cut so short here. I'm going to get this on in advance here, just on the, going to get the extractor here on the underside like this, and then if I rotate the board around, yeah, you can just about see I'm going to heat from this side here, 380 to 390 degrees, so a little bit cooler than I would do if I was removing the SMD stuff. And I'm just going to heat this area up. I'll heat the wider area as well here. If you heat the wider area and then zoom in, you can try and avoid delamination. If it delaminates a little bit, I'm not too worried, but I don't know if you can see from that angle, the pins are so short, even though 90% of them are detached, there's loads of solder on the top side, it's not flowing through very well. Yeah, it can be sometimes the problem you get working on some of these boards. So let's now just focus in, I think. I'm starting to pull a little bit here, just to see if it's starting to free up. I'm quite surprised how well that's holding on, despite the fact it must be getting, there we go, it's getting a temperature up. And yeah, you can see the pins moving now. Let's just try. Oh, is that way? Oh, yeah, it's out. There we go. And we've not got any through hole or anything there, so that was a successful removal. Just put that on the mat in a minute. Yeah, look, no delamination at all on either side, so I managed that. And that's the thing, so slightly less temperature, preheat around the wider area just for, I don't know, 36 seconds, and then zoom in and just go up and down the pins. But I think it's useful to remove as much of the solder off there as you can in advance. Anyway, I mean, you can see where, look at the delamination there, look at the difference between when someone else did that versus where I've just done it here. It's like a night and day difference, isn't it? So let's just move all my tools and things out of the way, and we can now try this without the ROM and see if there's any difference. Hopefully there will be. So still no signs of life, exactly the blooming same. Now obviously scoping all around the CPU and all around everything could help reveal what the issue is here. But I'm going to do the obvious stuff. There's a lot of delamination here under the CPU. So yeah, as your layers warp, I've talked about this before, the pad can move away from the through hole. And technically you'd think that the solder would flow down the pin onto the other side and join on the other side, but nevertheless you can get problems like that where you think you've got a join and you don't. So I'm going to, yeah, at temperature, I'm going to reflow every one of these vias here, just add like a little bead of solder. Yeah, so you can see it is looking a bit beady. Yeah, and the thing is with these as well, is like talking about these here, because there's no pin through them, this is where you can get a problem. If they do, you know, if the delamination does separate from the through hole, that is exactly what happens. You get a sever between the top and the bottom of the board. So just inspecting modification, yeah, loads of little beads there. Let's just flip it over and try it again. We can try with maybe where one of the other chips was delaminated, but the delamination was nowhere near as bad as where it was around the CPU. So the dead test is in. Let's give that a try. There is a couple of pins joined on the PLA actually, like a solder bridge from one place to another, which makes me wonder if something's been going on around the PLA. But no signs of life again. It's a really mysterious one, this. Here's the one I fixed in a previous video. I just put the 8500 in there. Just to rule it out, I put the 6510 on the other board, because even though it's got an 8500 on the C64C, it's the same. It's a 5V part. The only difference is it's a newer technology. The 8500 is it HCMOS 2 or something like that. And you can see that CPU works fine. But the main reason to do that is the 6510 I've put on here has got long legs on a dip socket and makes a really good fit. On that previous board you just saw, we removed a dip socket from a junk board, didn't we? Put it into the CPU position on that board. So it's got a turn pin socket, so the 8500 with its short pins on that board you've just seen fits really, really well. It was a really nice, tight, snug fit, despite the legs being short. So anyway, I'm going to leave them that way around. We'll leave the 6510 on here. I know that VIC is good. I know this RAM works, we tested this in the C16, although, yeah, it should work. It's dash 10, so it's a bit faster than should be here. We've now not got the kernel interfering. I think we've ruled out the vias on the underneath of that there. There are probably one or two around the chip here, you know, the VIC, but look, the delamination, there's literally, there's no delamination there, because obviously with that socket never came off. The CAA, yeah, there's the two vias there, but I can't see how that would be the issue. But we've got a bit of delamination here, so I'm just going to do the same thing, I think, under that CAA. Logic probe positive there. Simple stuff here. Reset on the CPU. Yeah, so reset, top right pin here on the CPU, switch it on. Low. Low. It's in reset, it's like reset. This is resetting. It's not coming out of reset. So it's got to be, I think, PLA. I need to double check to work out where the reset signal goes. On earlier boards you have like a 555 for the reset and stuff. I think it's probably all merged in there. That it could just be a PLA problem. It's not coming out of reset, but it could be that it gets buffered by, there's an 06 here, isn't there, an inverter, collector inverter or something, I think. So it could be something like that. So I just need to have a look at the schematics and see where that reset signal comes from. Yeah, it comes from pin 2 on the 06 here, so you know what? All may not be lost here, it could just be a balked gate. So if we just probe that, you're going to see the low. Let's have a look at its input. Hang on. High. No, it is high. I've actually got a display up then. That's the first time I've ever seen a display on this. Let's look at pin 2 again. I'm honestly not sure what's going on. I'm assuming pin 1 is input, but it's high. Let me see where pin 1 goes. I'm guessing the PLA. No. Ah, it comes from down here. Yeah, so the reset for the CPU comes from 306, it gets buffered, but it comes from here. So my guess is it's that chip. What's that? That's a 74LS14. First time I've ever had to look up the datasheet on one of those, so I don't know what that is. Bear with me, I'll go and look that up. Chances are I've got one of those spare, probably from one of the salvage boards in the past. Yeah, and I believe this is the problem. It's the one before the ground pin on the end here. So that's the output of this that goes to the 06 that gets inverted, and the inversion on the 06 is working. So the pin before is the input, and it's high. We've got high and a high. It's not inverted. That little Schmidt inverter is balked. It's not like something weird like they're doing the reset just with a capacitor or something, is it? Like something around here is the reset, and maybe like one of these caps is the issue. Could even be from the hot air. Like maybe that's a bit too big for a reset cap, but I don't know, maybe they... I don't know, I'm like just guessing here. There's a diode there as well, look. And another diode. Let's just test those two diodes, make sure they aren't balked. Yeah, that one's alright. I'm not sure I can get on the panel that one. Yeah, that one's alright as well, I think. Yeah, that one's okay. So it's not those diodes. I'm just going to consult the schematics. But the output of this, I've just held it to ground. Only after a period of time, so I let it go high, so the CPU reset is high. Then put that to ground, it goes through an inverter, then it's through an inverter, comes to here. Still doesn't boot. So, but this is the reset circuit. There's a 220 microfarad cap, a diode, and resistor. The diode and the resistor seem alright. I can't imagine the cap being the problem. I mean, it is a bit battered, let's say. But I actually think if you look at the high on this, and then the output being high, you know, it's got high input, high output, the output should be low. But then again, we don't see state change on the input to it, do we? Because I probed that as well, thinking it should change, which means the cap's not charging up. So I'm a little bit confused, to say the least. But yeah, it does look like this is the time delay for the reset. So let me take the 220 microfarad cap off, I think. Have an inspector around there, measure a few things, and maybe consider taking this off, because I do think that's balked as well, but there could be two things going on here. Maybe the diode is faulty, although it measures alright in the circuit. Yeah, that 220 microfarad cap's alright. 216 report, 0.09, and it goes ding ding, which, yeah, that cap is fine. There's no signs of leakage or anything. And it looks pretty clean around there. So yeah, the only thing is the diode and the resistor, I think, those two. So I'll check those, and then if those aren't the issue, I'm just going to remove this. So I just soldered all the points again there, and then use hot air to free it up. I've got the 74LS14 here from the previous one of these bread bins. It was in part 2, I think, where I removed the PLA. Well, I removed all the bits from that board, including that. So we do have a replacement Schmidt inverter there. So I just need to make sure the pins are all unblocked here and get a socket on. And straighten the pins on the chip I removed in the previous video. I don't think I showed me removing that. I did it off camera. But yeah, I did reclaim all the bits off that old bread bin board. There we go, that'll do. Right, there we go. So let's flip this over. We've got a new cap on our reset circuit. We've got the old chip here. Now the legs are a bit short on this because obviously, like I say, it was desoldered from one of these boards. I really needed a turn pin socket there. If this works, I may just order a new one of these and then they can fit one with longer legs in. So pin 1 was up there. It's a little bit awkward because I've got to sort of push that way ever so slightly. There we go, like that. Push it in. Right, let's connect up video and power and give that a try. Right, we have fixed the reset problem. If I probe this pin here on the 7406 and get onto it, pin 1. This is where it comes in, it gets inverted, but just watch it change state, watch. High low. Before it was just high. High low. So as that cap is charging up, it changes the logic level there, and then the inverter is inverting. So a bit higher up here on the CPU, you can see now we've got high, and if I just reset that again, low, high. So we've got a reset, but it still isn't booting. So I don't know, there's another problem, isn't there? The dead test should be testing though at this stage now, and it isn't doing. No flashes or anything. Right, still getting nowhere with this, but now we got the reset back, yeah, and I do see activity around the CPU. I need to scope it versus the pinout just to make sure it's doing what it should be doing, but I'm just wondering if it's like a cart slot thing. Maybe it's not disabling the kernel. Well, the kernel isn't there, but what I mean is it's not enabling things on the cartridge properly or something like that, or a bad connection on the cart. So to rule it out, let's get a socket in here and get the ROM back in. Yeah, I'll get a turn pin because look how short the pins are on that. And let's just see if it's booting without the dead test. But I do feel like positive progress is being made here. You could say it's embarrassing that I didn't spot the reset before I took this ROM off to start with here. But I've got another one of these. I think we've got the one we took off that previous board. Actually, it'd be nice to test that. I mean, maybe this chip doesn't work at the end of the day, but maybe there's a problem with the cart slot. It could just be another one of these where it's got a broken tray somewhere, bad cart slot. Right, that is the ROM socket on. We now need to get the ROM back in. The pins are so short. I don't even know if that's going to go into turn pin socket, to be honest. Yeah, the pins are pretty straight there. So let's have a go. Let's try and line it on the left side. Right, let's just push it in. There we go, the ROM is in. Let's now remove the dead test cart. So, still just the same. Now the thought does cross my mind that maybe this is a video output problem. Actually. Right, it's on now. Everything that is needed to boot is in place. You know, CPU, RAM, VIC. We're just missing 2 CIAs. I think what I should do is just check the video signal coming out of the VIC. Because it could be a video thing. Maybe this modulator is balked. Because I think the composite even comes from there as well. You know, it could be a transistor in here that's failed or something. Maybe we don't have a composite signal or something. Right, I've had a good scope around here. I am making no progress with this. It's you can see I removed the 4066 there just to rule it out because there's some weird stuff on the data bus. I actually think it's the PLA. I really do believe at this point in time it's the PLA. I don't think there's a missing connection or anything anywhere. I think that there was a problem with the reset which was resolved, but then I think the PLA's balked. So I've ordered some shrink dip sockets, some dip ones and some turn pin ones. But let me just show you. One of the thoughts I did have is this really outputting video? So I'm probing FB2 here. I'll show you where in a minute. It's a ferrite bead, and if I switch it on, you will see. There we go. That is composite. If I do a capture, do a run stop, and just change the not the voltage base, the time base there. Yeah, you can see like you've got the back ports and stuff, and that's the composite signal. And while the frequency there's not correct, 500 kilohertz. So just do a run stop. Just watch the. I'm just not doing it now. Let's just zoom back the other way. Why is it not giving me a frequency? It was a minute ago. Let's just do auto on it. That's interesting. Maybe I need to go further out. Yeah, you need a larger sample window, that's what it is. If we go further out, so this is 15.63, that's sort of standard definition frequency. So yeah, we're getting composite out, so we are getting a black screen as the TV is presenting. But if I look down the data bus here, so this is like D0, let me just do auto on it to rescale it and stuff. Yeah, so it looks really messy, doesn't it? That's D0, D1, D2, D3, D4, D5, D6, D7. Yeah, so it's just a mess, you know, if you do a capture on that. Look at all these little jaggedy bits on the top. And this seems to be a bit intermittent. I'm holding it on that data bit there, it's the last data bit, switch it off and on. You sometimes get different behaviour. I mean, that wiggly bit could be because I've got an extended ground here at the moment, actually. Let's just try and move the ground nearer. No, it's not. So, I don't know. There's just something really weird going on. It's got to be that PLA. I don't know what else it could be. I even went out with a logic probe around the PLA just to make sure the connections are getting to that. I checked the data in the address bus between the CPU and the ROM, the CPU and the RAM. I checked the output enable on the ROM. I checked the write enable on the RAM. It's like everything seems normal, but the data bus is just completely messed up. This is why it's not booting, I think the data bus is not right. And the thing is here, we've got no CAAs on. I removed that 4066 for the VIC there, so it can't be that. There's nothing really to interfere with the data bus as such. It's got to be a timing thing, like something's on the bus at the same time, because remember the VIC shares access with the RAM. The RAM's not even there at the moment. So I'm still waiting for that socket, but anyway, I've continued on just probing around here. Just switching it on, you can see I've not got a VIC in here at the moment. The reason being is I know it's it's a single up socket. I thought, is it this socket? Well, one of the pins here was a bit dirty, cleaned it up, got some contact cleaner in. But then I thought, let's just probe it, and I went down here like this, and I got to a pin where it was high impedance there. And I'm like, why is that high impedance? And this was with the chip in. So I took the chip out, and I've continued doing the same thing. 1, 2, 3, 4. Yeah, it's that one, pin 35. Look on the schematic, that's D11. And it comes across to this pin here on the RAM, which is also high impedance. Now the other data bits aren't. I've seen this before on these RAM chips, where these RAM chips somehow cause some sort of PLA issue. It's like you cannot boot at all, even though just the colour RAM's faulty, or it creates a PLA fault when you do a test. You do a test of the system, and it comes up saying the PLA's faulty, and you get weird things going on. But nevertheless, that RAM, I think that colour RAM has a fault because that bit is high impedance there, as you can see. So, that's very strange. I think I may just remove that RAM. I mean, I'll show you, if I just switch it off, stick this back in, you'd think that with this driving it, it would, you wouldn't have a problem. Yeah. So I'll do the same thing. 1, 2, 3, 4, 5, flowing. Yeah, and here, flowing. But other pins around this, I'm not sure which ones the data bits are. We have outputs, you know, we've got pulsing on one side there. So, yeah, I think that colour RAM is balked. I don't think that's the entire problem, I just think it's a problem. So, let's now remove that, socket that up, get another colour RAM in, and just see if that springs this to life here, that pin, or whether we've still got a problem. Soldering the socket on now. I'm going to test it without the chip in there to start with. Yes, that has solved an unseen problem. So we would have got to colour RAM fault, and we can test that if we do get this up and running. Well, whenever we get this up and running. I still think the PLA is the issue, so 40, 39, 38, 37, 36, 35. Is that one that was flowing before? It's not flowing now. So, yeah, it had a bad colour RAM as well. So that's 2 problems so far. Reset problem, colour RAM problem. This logic, as far as I can see, seems to be alright. I mean, we've got the ROM in there as well as the what's his name, diagnostics dead test card at the moment. And I've tested connectivity until the cows come home on the PLA and the, well, I say the PLA, you know, like everything to do with disabling the kernel. Yes, if you ignore the massive white glare, it is still just giving us a black screen. So perhaps an obvious thing in retrospect, I really should get that 4066 back on, because the VIC can't interact, well, I think can't interact with the RAM without that, can it? If I'm thinking correctly. It's quite a small chip, that, actually. So again, I've got a 4066 off that last C64 C board. I mean, I've got some new ones anyway, but yeah, I've got the chips to hand here from that, the one we stripped down in part 2, I think it was. Anyway, let's get a socket there. Right, let's get a chip in. Yeah, I've got one of the 4066s here from the previous board, so we'll just flatten these pins down. Right, let's get this in and see if that makes any difference. I don't think so, but you never know, stranger things have happened. Well, I've got a couple of these chips, and I'm still waiting for the socket, but you know what, curiosity got the better of me, because the pins are really taut on this. I thought I bet I could just put this on there, set that right over the top and make a snug fit on all the pins. And indeed, the pins are really straight on this now, and I pulled one side and pulled it over the side and slid it down, and it's tight on all the pins. If you watch the screen, this is the first sign of life we've had. Look, and it's consistent. I've reseated it a few times. It's really tight. It is really tight on there on all its pins. So I think that confirms it is the PLA. Actually, I think when we are able to socket that, we will have fixed it. I can't get the PLA off now, it's that tight. Yeah, so without the PLA on, nada. So yeah, it's a PLA problem. And of course this means that it hasn't really been much of a repair, has it? It's been more of a, let's build a C64 and remove the few faulty parts that are left on it, because we had a reset problem. This RAM is faulty. I can show you the old one once we get the good PLA on there. I mean, I could just take that off and solder this straight on, but you know what, I prefer to socket them. Because I've got another PLA of the other model that I want to experiment with anyway, and I think this is the type that has the RAM. I've got another one of these that doesn't have the RAM. You know, it's got it internal to the chip, so I can do that test as well. Dead annoying though, isn't it? The funny thing with that is, it's like I've been saying these are rock solid and never seen a faulty one, and then the first one of these boards that I have a go at fixing, it turns out the PLA is faulty. Technically, this one could be faulty because this is the one that came off in part 2. So you never know, there could be an issue with this. And actually, this may prove nothing. That might be alright. This balked PLA might be causing problems. So anyway, I think it is the PLA, and I think that's evidence of that. So the sockets have arrived for the PLA here, the shrink dip 64 pin. This one's actually a dual white one, which I didn't even realise you could get for these, but anyway. I've got 2 turn pin ones on the way as well, but let's just go with the one we've got here. So the dissolve station's warming up. Just clearing the end here because yeah, there was a small blockage last time I used it. But to start with here, I am going to use the desolder station and not the solder pump. So let's start up here. I've got the smallest nozzle I can fit on this, and as you can see, it's doing a good job of removing the solder there. Pins are so short on this. Oh, it's like I can't even get onto the blooming thing. This is where a dual wipe socket could be a problem actually. I may wait for the turn pin. I'll see how long the pins are on the other chip I've got. Anyway, I'll report back.
Of sadness, the anxious
So anyway, you get the idea. It's about 5 done and 60 up to go. So on macro there, you can see how the pins look. There's one or two where I've just rubbed a little bit, but that will clean up in a minute. And flipping that over, you can see the gaps around the pins there. And yeah, that's exactly what we need. So most of them are free. There's just the odd one, I think. It's hard to tell on that light. So again, I'll just do my usual, just to grab a few and pivot. There's very little to grip here. That is solid, so yeah, I'm going to have to flick each pin at a time on the underside with my metal prodding tool, and just to see if we can work out which ones aren't free. And what I mean is a bit of this, like that's not free. Yeah, see that one is twanging. Right, so they're all making that twanging noise as I flick them. So I think we are in a position to start to try and lift. Maybe not, because it still is not moving at all. Oh, there it is. It is there. Let's just leave it here a little bit. Yeah, there you go. So yeah, I'm pretty sure they're all broke off. The big problem with this is the pins are so close together, because you've got 64 of them, it can give you some resistance, but do make sure when you flick them they twang. I would say on one side, 3/4 of them were still not twanging, and you just heat with the iron. You've got the iron here, heat the pin, and then as you push the pin, just twang it, you know, flip it, and you'll free it up. I've shown that technique before, but there you go. No through hole, no damage at all. Removed. So we'll just clean up around that with the fiberglass pen, just lightly, cotton bud with IPA, and get the socket on. Anyway, it is generally very clean under there. There's not any damage or anything on those traces as far as I can see, but I will inspect with modification just before I stick the socket on. So let's try and get the socket on. I'm not sure the pins are as straight as they should be on this socket. Oh, one side's gone straight. Yeah, I can see them here. Let's just use the dowel. I think there's one of these ones here, wasn't it? I'm just going to do 2 or 3 there. All I'll do is press in and rotate just on the very surface. It's easier. Hang on, a pen's falling out now, look. It's easier than just trying to repeatedly unblock them, etc. Let's see if we can not lose that pin. Push this one back in. Right, after several minutes of messing around, getting the pins back into the socket, making sure that they're all the same height on both sides there, and using the dowel on several of the holes, it's gone on. So I just need to just flip this over, solder a couple of points, do inspect at this point, make sure they are all through and none have folded up, and yeah, they are, and then just solder it on. So the socket is soldered on. I'm now just going to revisit the replacement PLA here. Just make sure all these pins are as straight as they possibly can be. Pin 1 is up here. Let's just see. This may go in easier than it would do into a turn pin of the same type. Shrink tip sockets, never fun to work with. That's going to go in, I think. Now, I'll just inspect with the magnifier here, but that looks like that's gone straight in. Composite lead is connected. Plug the power in. See what happens when we switch it on. Switch it on. It's on. Nada. Well, that's interesting. So we've still got a fault. Nothing's getting hot here, so I don't know, that's a bit strange. Let's put the dead test in again. I am wondering now if there is another fault on this board. Maybe the PLA isn't the issue. Oh, now look. 1, 1, 1, One, got a RAM fault. Yes, the RAM fault would relate to these. The interesting thing is, these are brand new chips. Let's just try swapping these over. I am wondering if I've got the wrong PLA in here actually, maybe it's the one that doesn't have the colour RAM. I need to check that. That socket there is not so clever, is it? Bear in mind I didn't fit these sockets. Alright, let's try again. One flash. Yeah, so it is getting further. So let's switch that off. Now the interesting thing with that is we know it's not the RAM because we swapped the RAM around and it would be a different, it would flash a different pattern because it would be a different data bit. So let me try removing the CIAs here just in case one of the CIAs is causing the problem. So I've removed the U2 here. One. Let's remove the 4066 actually, because I think, doesn't that set the data bus? I'm sure it does. It just could be a bad 4066 because I'm not sure whether that's the original one that was on here now. One. Let's try removing the kernel. I'm thinking something might just be short in one data bit here. Of course, it could just be a RAM problem. It's not flashing now. Now the kernel's been removed. Look, there we go, we got a bit further. So yeah, we got a kernel fault there. I think we may have a character on fault there as well, because that's strange, isn't it? Why is it doing that? Let's now get the CIA back in. I'm going to switch it off. So yeah, this is one of these boards with multiple faults, isn't it? It had a bad PLA, it had a bad IC responsible for the reset there, I forget which one it was. Was it 14, 7414, and a bad kernel, so three bad chips on this board. So it's got the CIA back in now. Let's just see if that changes anything at all. I don't think so. I do think we've got a character ROM problem or something like that. Yeah, can you see it's kind of like the colours are a bit strange here? Yeah, so I don't know, we've got the blue here, but we're sort of seeing the same issues with the colour there. Let's switch it off, put the colour on back in again. I honestly do not know what's going on here. It could be a bad connection somewhere. Yeah, it says colour RAM bad. So I actually think this is the PLA that has onboard colour RAM actually. I removed the 4066, didn't I? That was the issue with the colour RAM. I actually swapped back to the original colour RAM. There was a fault with that, I'll show you that in a minute. So we had a bad kernel, a bad colour ROM, and a problem with the 74 LS14. So yeah, there wasn't very much that's functional on this board. Character ROM seems alright at the moment. The colours still aren't very vibrant, but anyway, let's see what it reports here with the colour RAM now. Yeah, that's looking alright. Sweet, I think we'll call that a success. So we've got an ARM set in there at the moment. We've got we need another kernel, don't we? I've got another kernel. I'll just try another one. We'll see if basic comes up, and we'll just try a few games. Yeah, hey, and we have sound. Sweet. Timers are good, so the two CIAs are fitted are okay. Well, with respect to the time of day stuff. Need to test keyboard, serial, joystick ports, etc. So yeah, very pleased. Another successful repair. So let's just I need a kernel for that. So this one's balked. I'm not even sure if that was the one that was in here actually. You may think, oh, that isn't the same print, because I have the other one from the other board, I think, and I'm not sure whether this is the one from part 2 or whether that's the one from part 2. Anyway, let's get this one on. It's got very short pins, so this is where you absolutely need a turn pin. It's barely in there, even with a turn pin. Just literally breathe the wrong way and that won't make a connection. So let me power it on with that in. Yeah, we haven't got any flashes, so yeah, all signs are that kernel / basic is okay. Let's just take the dead test out and just see if it's basic. Come on, give us basic. It's not giving us basic. So maybe the basic side of that is balked. This is the thing, isn't it? It's like one half of the ROM might be alright, the kernel bit, and the basic bit can have an issue. I think we should just let that dead test go through again. Does that test the kernel or the basic? It doesn't test the kernel. I'll tell you what, I think we actually need proper diagnostics in. Let's just put Navy seals in, see if that works. Because if that works, it might be just some evidence that it's just basic that's balked. So that's Navy seals. Hang on, let's just power cycle light scrunched up. That's just this TV. There we go. See what happens, Neil. There's a block top left there. I never noticed that before. Yeah, that's working. Let's see what the graphics and stuff look like. But all signs are then, it looks like basic is balked on this ROM, kernel is balked on the other one. I think just for good measure, I may actually just take this back out, clean the legs with a fiberglass brush and put it back in, because I kid you not, there's like 0.5 millimetre of leg length or something. It's like it's barely making a connection to that socket. Yeah, you'll see what I mean if I just use this extractor here. Look, it just came straight out. There's barely anything. Let me show you the length of the legs there. Look, there's literally nothing. There's literally nothing to go on. So, yeah, it wouldn't surprise me. I may even just bend these outwards a bit, so that I have to tilt it inwards. And go in. Let's try that. No, the exact same thing. So, yeah, basics balked on that one. Oh, joy. I need to go and find a replacement ROM then, don't I? So just to rule it out, I swapped the PLA again for another PLA. So this is the one that you saw me remove ages ago, about 6 years ago, 7 years ago maybe. Yeah, both of these behave the same. It's the character ROM, has to be. And we can prove that by loading the Kung Fu Flash. I'll show you, this has got Ghosts and Goblins loaded. So our graphics are fine there. And I'm sure that game works. I haven't got a joystick connector, but anyway, if I press the menu button, watch. There we go. Because that's going to be using the character ROM. I'm sure that menu is actually working. But what's happening? We're just getting random garbage here. Noise, more or less, coming back from the character ROM. Now, it could be the chip select for the character ROM, so I will check that with the Logic Probe first. Maybe one of the 7.4 series that's still on this board that hasn't been replaced is responsible for that. Right, the chip select comes from the PLA. I have no reason to believe the PLA is the issue, because obviously we've tried a couple of different ones. Solder points look good, traces look good. I mean, it could be corrosion under here, but I seriously doubt it, so let's just use the desolder station on this. Right, I'm going to remove it with hot air, because even though the solder station did a really good job on the underside, as you saw, there's tons and tons of solder on the top side. It's literally not passing through at all. This is what I hate about some of these boards. Yeah, so anyway, we'll heat the wider area. There's a long leg there, what's that? Might be from something I fitted on the other side, I don't know, cat maybe. Some spacing from the other side. There we go, it's come off. So I'll just let it chip down somewhere. So just look at the board around, you can see the position there, no damage on top or bottom. So I just need to make sure the holes are nice and wide and get a socket on. The turn pin would have been better here, because the chips may be short leg ones. Yeah, this top left edge needs to go slightly more that way. Right, so let's try a different character ROM. I've got one here, it's got pretty short legs. This is the one I think came off the C64C in part 2. Pin one towards the top. That's it. Right, let's give that a try. Switch it on. So that works. Let's hit the menu. Hey, there we go. That's what it was, character ROM. So we should have basic now. Switch it off. And we can remove the Kung Fu Flash. Switch it on. We should get basic. Hey, finally, we are there. So, yeah, that was quite a troublesome little C64. Bear in mind when these faults originally occurred with this, it probably had other things faulty. I saw a number of C64Cs like that where you'd have one bit, it was reporting that one RAM, wasn't it? You were getting one flash on the diagnostics after we swapped the PLA. So it killed the PLA, the reset circuit wasn't working, the ROM was the reason it was given the one flash there, because one bit, it was interfering on one bit on the data bus. That's what was going on there with that ROM. But when you get that, it often kills the same data bit on the CPU, the same data bit on the CIA. The VIC usually survives, they're pretty hardy. But yeah, I've seen that. In fact, the one where I saw that happen, it killed both CIAs on the same data bit. It's like one data bit kills everything else that's connected to that data bit. So yeah, very interesting. Anyway, that is working. So the only other thing I need to do is just retest with the PLA from the previous board there, from part 2, the end of that. But I think that works. We were getting exactly the same behaviour. Everything was working except for the character ROM, the graphics in BASIC, and anything that makes use of the character ROM was not right. E.g. the menu in the Kung Fu Flash. So I think the only thing to do really is just play some games on this, test this out, and then give it a good clean. I've got the original colour RAM back on there now. This is my replacement, and if I show you what's going on, you can see that? Yeah, this text is yellow. Straight away, that shows the problem. That's that floating bit. I told you that one of the bits is floating on there. Yeah, colour RAM, bad. And with an own good colour RAM, it's perfect. So yeah, that's like the 4th part I've had to, or 5th part I think I've had to put a cross through. So the next day and the next problem, it works okay this, but the up direction doesn't work on the joystick. Let me show you. So if I hit fire, I've got a different joystick here, just ruled the joystick out. I even cleaned the connector up just in case. Now the port could be the problem here, i.e. there could be a dirty connection there. I can't move around there, but anyway, hit start. Start again. Now up should jump. Up ain't going up. You can go down, and go left and right, fire. And I'll show you this. Hang on. Watch, up. Yeah, so up just ain't working. 2 different joysticks. As I say, cleaned the connectors as well. So the next thing when you get a problem like this would be to swap the CIAs around, because one of these here handles the joystick. I'm not sure which one it is, but anyway, swap them around, same behaviour. Now that's good news. It shows me that the CIAs aren't the issue. It's going to be a trace, from one of these CIAs somewhere. Maybe some corrosion on the up pin here, or a broken trace. It could be one of these EM components here. Maybe one of these has been fractured, or maybe someone tried to take it off, or maybe it's just failed. It could even be a bit of corrosion or something localized around there. So yeah, I think that's the next thing I need to inspect is the connectivity from here to here, and then from here to whichever CIA. I'm guessing it'd be this one because it's nearest, but it might not be. The one over there, I know it's the serial port and stuff, but it may do the joystick ports as well. I forget. I think the ports here may be for the keyboard. I'm not sure. So if you're a regular viewer of my channel, you'll know that we've covered joystick ports on Amiga quite a number of times actually. And I usually show using a logic probe. You can connect your logic probe up, and then you can just have some power, and as you move up, down, left, right, you can probe the pins around here, and you can see the activity, and you can work out whether you've got the expected activity of changing from a high to a low as you pull in the direction, and then as you release it should go high again. But this time I thought I'd show you something different, just using a multimeter and continuity test. So we've got the black probe here in one of the ground points there, so if I touch a ground point on the board, you can hear a beep. So if you probe around the pins here, there's 4 pins on the left here. That one's ground, 000 it's showing on continuity test. That one there is showing 0.007, that's going to be 5 volts, I think, nothing. So that's those 4. The 5 here are the directions. You might get a little blip, but then nothing else because no directions are pressed. If you had a beep there when you're not pressing the direction, that would be an indication of a fault. But anyway, if I press left and then just move down here, there we go, and I can release and press left. Here you can hear that's working. So it's toggling between low and open circuit. Well, it's not necessarily open circuit. There's probably a resistor or something like that. Pull up. So if I press down, that's down, and right. That's right. So up not that one. It's not that one. It's that bottom one, I think. So press it up, we get connection on that bottom one there. Yeah, the bottom of the 5 on the right. So up is working in terms of the joystick, the port here. Yeah. The next thing to do is, again on continuity test, now we know that this is the bottom pin, is free our probe up and test from there to these EMI things here. It's going to be one of these, probably the furthest one away maybe. And I'm not sure which side it's going to go to, because that one there, 4th one down. Just testing the others just to make sure. Yeah, so it's that 4th one there. At this point, what I will typically do when I'm working on something, just because you can wipe this off, is just draw a little red mark there. I now know exactly where it is when I'm messing around with the board. The next thing we could do is measure across these. So if we go from there to there, yeah, you get a short across, and then there's a capacitor that joins to the ground in the middle. So like, that one's a short, that one's a short, so we know it's not that. That's a short. Yeah, so all these are a short across here. Measure to the middle, make sure there's not a short. Nope, there's no short there. That side and there. But I mean, bear in mind there's a short across there, so you'd expect from either pin to the middle, if there was a problem, you'd get a bleep. Ah, now here's the difference. This one's showing 557 millimeter, 5 something. I think there's a pull-up resistor or something missing here somewhere. 528. 528. Roughly 528 on all these other ones that work, but not here. So what's happening, I think, is it's missing a pull-up. So maybe the centre point goes to the 5-volt rail. See that there? Yeah, so the centres are all joined together. So see, is it ground? Yeah, it is ground actually. So the centre goes to ground, but we don't have a short between. Hang on. I was going to say we don't have a short between there and ground, but we did for a second there. Maybe I was just pressing the wrong way. So it's not like it's short to ground. What seems to be happening is these ones are showing 5.7 something. That one isn't, which shows like a pull-up is missing, maybe. So I guess the next thing is to just have a quick look at the schematics and see from here, is there a separate pull-up resistor that feeds into these? The CIAs themselves have an internal pull-up, but the CIA we know isn't the problem. I know I didn't show you that, but I swapped the CIAs around. So the chances of the same pin on the same port on both chips having the same issue is slim to none. So I think it's likely to be, a pull-up somewhere. I don't think it's this component, because this component simply has this it passes the connection across. It's like an inductor. If you saw the C16 video I did recently, you may not have seen it. If not, it'll follow this one. I swapped one of these little EMI components with a ferrite bead. Just put the ferrite bead across the outer connections there. The centre pin you don't need to do anything with. That is just a capacitor in there. The third point, middle point goes to ground. There's just a capacitor in there on the signal as it passes across. It adds a bit of filtering. That's all it does. So yeah, anyway, I'll report back when I've looked at the schematics. Yeah, I'm not seeing any resistor networks that are large enough actually, so it must just not be getting to the CIA. Unless there's a missing component, there's some stuff here that could be arrays. Maybe someone's took the resistor arrays off, but then again all the other directions work, so I don't think that's the issue. It comes from this bottom pin here. It was the 4th one, wasn't it? So if we test to one of those there, so you can see we're on the 4th of these here. This is the opposite side we were looking at a minute ago, obviously. And if you follow the traces, they come all the way down here, and it goes to one of these here. And it goes to there, actually. So I've just labelled that incorrectly. I've stuck a little red mark there. It's actually that 3rd one. So all I'm going to do is now flip that over, see where that wire goes, and try and follow it. It's going to go to either this CIA or the other one. I actually think the trace is going to be broken somewhere in between. Yeah, looking at the schematics, it does go to U1, the CIA here. Remember I was talking about delamination a number of times on these videos? I traced the thing to there. So let me just show you. Yeah, so it goes to one of the pins on here, which comes out to pad there, and I follow the trace, it goes under here. So I remove the CIA, and lo and behold, it goes to this via underneath. And I've soldered these with a bit of solder here because of the delamination. Maybe it would join it back up, but yeah, you can see got joined there. I bet if we flip this over, it's not going to be joined on the other side. I think that's what the issue is. So yeah, I think we need to get that hole unblocked, get a piece of Kino in there, and then resolder it on both sides. So that'll probably solve it, I think. If I just measure from the you know, the EMI thing we marked over there, there were a few places actually, weren't there? There were these vias here. So that was on the top side, one of the ones are marked. Then it came out on the bottom one of there, yeah, and then it went on the other side to one of these here. And this is the thing. Look, nothing. I think it was the one nearest here because it went through this side here. So that's all it is. So actually what I'm going to do is just join a wire, because the via will be unreliable. Mind you, it will be alright to stick Kino through it because the pad will be soldered on each side. But you see what happens is, you know, you've got two layers like that, and in the middle is, you know, if you imagine, you can see there's the through hole. Yeah? As soon as it delaminates, it pulls away like that. And when all you've got is solder through there, you can have solder on the top side, solder on the bottom side, yeah, solder going all the way up the internal of the via, but it's not reaching the other layer because the layers have separated. Yeah, that is the problem. So anyway, I think the best way to fix a via like that is probably to just have a wire, actually. So we'll stick it from here to there maybe. Right, so I changed my mind there, you know what I'm like. Anyway, at least I talked about the way you could do it, you know, with a fix from here to there. But I've just got some Kino here, and I'm going to shove it through. I've just unblocked the hole, I think. Hang on. There's nothing under there, is there? What is going on here? Where's that not coming through? Yeah, this is the thing, you see. So I've removed the solder from here. On the other side, the solder's still there, even though the hole is completely unblocked here. That shows that there's like a cavity in between, and it's like it's not melted here. The heat's not passed through to this side, which means it's a gap, just like there's an air gap between them. So yeah, we need to do the same thing there. That's it. Now the Kino should go through. Yeah, so I'm just going to feed it through the hole there, like that. You want quite a long piece, and then you can, you know, cut it down to length and stuff. Once you can cut it down once you've got it in position on both sides. So yeah, I'm going to block the camera with the angle on that here. Just add some solder there, and I'm just going to just push that kind of in there like that. Leave it connected here. Don't cut it at this side. Flip it over. Just bend it over a little bit so we're at an angle. You can see the Kino there, I think, just about. And we'll solder it on this side. Because it's still through, you know, quite large on the other side, it won't just fall out. And then you can trim it off, because we now know it's soldered on this side and it's soldered on the other side. So I'm just going to add a wee bit more solder there, actually, because that's a bit minimal, let's say. That's it. The final thing to do now is just bring the cutters in and trim it off on this side as near to the point where the wire comes out as possible. There we go. There we go. So there's our little fixed connection, and we can get the wrist strap back on, CIA back in, connect it all back up, and all being well, we may be able to jump in Ghosts and Goblins. So let's press that in. Yeah, it's not a very tight fit, that, because it's got really short pins, that CIA, and that's something else to consider. You know, is it you connected to your CIA? But as I say, we've had these round the other way, and the other one's got really long pins, so same problem with two CIAs. Something else I didn't mention here when I was trying to diagnose this, I removed this from the equation, the saver. The reason being is you can get voltage drop, and I cleaned this. If you get a little bit of voltage drop, sometimes the internal pull-ups on these CIAs, if it's suffered any damage in the past, you can find just the voltage difference between, say, 5 volts and, I don't know, 4.7 means that it doesn't register. Yeah, but you get 4.8 volts or more, and then suddenly that direction works again. I've seen CIAs that are marginal like that a number of times. So yeah, I did just remove that from the equation to get a slightly higher 5 volt level, just to rule it out as well. That was one of the early things I did. Anyway, let's get the joystick back in and switch it on. Oh, hang on, the kernel's popped out. I'll show you that in a minute. This is what I was talking about, having a turn pin socket. Yeah, that's hang on. Oh god, that TV's so annoying. Yeah, the kernel seems to have a tendency to just pop out. Right, there we go, about 10th time lucky powering it off and on there. So start. If up doesn't work now, I'll be very, very surprised, but you never know, there could be a problem with the joystick port yet as well. I need to check both. Hey, we can jump. Fantastic, there we go. So at least that one was a simple fault. Yeah, the keyboard's connected up and it's all working. And the SD to AC is working via the serial port as well. The only other thing I need to test there is the data set, I think, so I'll perhaps test tape in a minute, try and perhaps load Uridium. I tested the two DRAMs that came off the video in part 2 actually, that C64C board, both balked. One of them actually had a crack on the underside, so I'm guessing there must have been some sort of voltage problem on the other board. And that is, I think, what kills these. I think this is what's happened to this one. I actually think it's been an overvoltage situation rather than one data bit failing somewhere or something. It doesn't help the 8.3 file name there. I can't tell what anything is. We've got Stunt Car Racer or something there. The SD to IEC I highly recommend, by the way. You can get these from the Futures 8-bit. They're really nice, aren't they? It's like a little replica floppy drive there. It's even got the Commodore badge and everything on the front. This one's an unusual colour. It's like dark grey. I got this free actually with the C64 I bought. But they come in all different colours, you know, and you can get the replacement shells actually. You can change the colour of, you know, if you've not got one, or if you've got the PCB without the shell, you can get a replacement shell for it. But yeah, check out the link down below for Futures 8-bit for these. They're so useful because they're affordable, they're cheap, like, I don't know, just under the £40 mark I think. And obviously it uses the serial port, but it means it works on the VIC-20, it works on the C16, and it works on the C64 and the C128 and stuff. So yeah, they're really useful to have. It's a good way to test the serial port. The disk drive emulation's a bit hit and miss. In other words, copy protected stuff generally won't work properly. You know, certain ones that use like a custom loader on the actual drive itself, you know, they won't run. Infinite Shields, no. Oh, it's Empire Strikes Back, look. Yeah, that seems to work. But yeah, I mean, the Kung Fu Flash is perhaps a better cart now. Again, you can get those from Futures 8-bit. But obviously it's not using the serial port, so you want one of each really. You want a cartridge solution, you want something with the serial port. So we're in port 2, let's just see if that works. Maybe we're not actually, I think we're in port 2 already, I've just put it in port 1. That's one thing that never gets old on the C64, is like the fact that some things are port 1, some things are port 2, there was no standardisation. So we can move up, down, left, right. Yeah, up, down are inverted on this, aren't they? I think that was just the way the game was. But yeah, up, down, left, right and fire are working as expected. Mind you, we're on the same port we were before, so I need to find something that uses the other port. Pretty slow, this version. So I think I will probably end up sticking a few sockets on this. Just switch this off. This chip here, like I say, you can just literally, look, tap, and it just comes out. It's like literally held in with nothing because the legs are so short, even with a turn pin. So yeah, without a turn pin, there's no way that would stay in a dip socket. What you could do is find it, get a socket, a turn pin one, solder it in, yeah, and then stick that in there. Yeah, then it's going to be a reliable connection. I'm talking about not just for your own use, but say for instance you repaired and soldered this. Well, it's just going to come out in transit. Once like knocking the post, that chip's going to be half in, half out, and someone's going to be using it for a few hours with some heat and cold cycles, you know, hot and cold cycles. It's going to come out on one side, because that's what's happened with me a number of times with this. You know, I'd just take one chip out, for example, here, and then put another one in, and suddenly it's black screen, and I'm like, oh my god, what's wrong with it? And then I realise it's lifted out on one side here, it's just fell out, just with the just banging the board like that, it's lifted out, it's fallen out on one side. So yeah, what you could do is, let's say, solder it straight into a socket and stick the socket in, but also I'm just going to get some hot melt glue, I think, just melt some there over the socket edge and the chip. Do the same on this side over here, just to kind of hold it in. And actually I may not do that. This is going to be a test board. It's got lots of things socketed, nearly everything socketed on this. What I might actually do is socket those two up, and then everything is socketed pretty much, with the exception of the 4066 right down over there, which I'm not interested in because one of them's socketed. In order that I can test behaviour, test chips and things, that's always a useful thing to have. Now this is not ZIFed, is it? There's no ZIF sockets on here, but I have some ZIF sockets spare. I think what I might do is remove this socket that I fitted, relocate this transistor and this resistor here, and try and fit a ZIF socket there for that, and then it will hold really firmly with that chip, and it means like I've got a way of easily testing some of those moving forward with a ZIF socket. I'm just loading iridium from tape, and there we are, all loaded. Of course the aspect ratio is incorrect there. I can change that on this TV. Yeah, that's more accurate. Now the interesting thing, testing the other chips here, I've got 3 or 4 of these that came off the previous C64C, and I probably mixed these up as I was taking the chips off of this board as well. This 4066, was it an NEC one? Not sure, but nevertheless that chip is balked, so I think that was perhaps a fault on the previous C64C that just had a few chips that were reclaimed from in part 2. Now it may scrunch up the top of the screen here, but look, solid blue screen. Yeah, it's not passing any colour data, or maybe even interfering with the data bus there actually. If we take that out and put the other 4066 in. Right, that's in, switch that on. Yeah, so that 4066 was balked. So give it a quick clean and then we'll just test 1 or 2 new pieces of homebrew and stuff. Yeah, as you can see, there's some delamination in there. That's looking pretty clean. I need to clean further afield though, yeah. Yeah, I need to go further up here now as well. There you go, you can see how clean that is all around the PLA, all the chips up here, all the chips all around there actually. It almost looks factory. The interesting thing though is you can see where the delaminations occurred from somebody else who delaminated that, and it's the same down here just to a lesser degree. But obviously all the chips I've removed, we've got none of that, and bear in mind these little ones here, those were removed with hot air, and there's no signs of any heat damage, so that just goes to show someone's gone too high temperature, but also remove the solder before you use hot air, and then it just comes off within a minute. And obviously preheat, that's the key. Someone preheated around here like that, 400 degrees for 20-30 seconds, going up and down around and stuff, and then focusing on the pins there. They probably wouldn't have got this massive warpage here, and this is why we had to have these little beads like this, just to make sure that the connections are all the way through. Guns and Ghosts here. I discovered this on the Highlanders channel. It's got a cool channel. Check him out down below. Is it run stop? Yeah, there we go. Yeah, I like this. Last time I played this was in the summer this year actually, and I played it for a good few hours. I was absolutely hooked. It's a really simple yet addictive game. Isn't that the way of most C64 games? I think so, or 8-bit games in general actually. So if we hit run stop, hang on, trainer, high score 1, load, hit fire. So you get some little cutscenes and things that introduce the story. Dead simple, you just shoot the zombies and you have to reload. Hang on, yeah, you got to not fire to reload. So as you press fire after you've run out of bullets, it then reloads. So, oh hang on, it came up underneath it, didn't it? Yeah, it's tactical, you've got to keep track of the shells on the left hand side, because if you don't have a shell ready, the zombie will get you. Playing very badly here. And of course there are power-ups to reload quicker, to give you more bullets, etc. You can have more shells. There we go, free now, look. Yeah, it's really cool. There's loads of levels. You can get a boss at the end of, after so many waves. I think you do like 7 or 8 levels and then you get a boss. Keystone Capers was one I only discovered the other day, but I don't think that's new. I think that's an oldish, well, number of years back. It might not even... No, I think it is. I was going to say it might not be a piece of homebrew. It's really cool though. It kind of reminds me of Bonanza Brothers, but yeah, dead already. Oh, I thought it was. Yeah, I think you have to collect all the bags of loot and stuff, don't you? And you got these lifts, I think. How you use them, I don't know. Age of Heroes, I think that's a new one. Yeah. Looks pretty cool. I think the C64 must have one of the most active, homebrew communities. It is incredible how much new stuff there is for the C64. Give it a month, there's usually a new game out. There's almost as many new games out as there were back in the day. Well, not quite. Yeah, it's pretty cool. Yeah, cool. So you've got different areas and stuff, a bit like some Mario World, whatever it's called. Oh, level up. So you've got a level up system as well. That reminds me of Gills and Ghosts music. One interesting thing with this chip, actually, the PLA that died on this. Can you see there? It looks like it's a Yamaha manufactured part. It's got a YM part number at the beginning. I think that indicates it's Yamaha rather than Sharp. Now, Sharp made most of the PLAs for these 664Cs, but yeah, post your comments down below. Am I right? Am I right in thinking that's Yamaha? Because if you look at the Sharp one there, it starts LH. The Sharp ones always start LH with the part number. But this one definitely starts YM, so yeah. Is that something to do with the reason it's failed? I don't think so. I do think it was an overvoltage situation on this. So back over to the Ziff 64 here. There'll be a link top right to the video where I covered this. A bit of fluff there, or a hair or something. Anyway, let's just switch this on. Let's make sure the voltages are alright, yep. So just testing the character ROMs on this. So this is the first one here. Let's switch it on. Woohoo! That one's good. Now, you would need to do a little bit more extensive testing here. There's a bit of flickering going on there, do you see that? Yeah, you need to do a bit more extensive testing in order to test all the characters are correct, but in general, if it comes up looking okay like that, it's probably going to be okay. Surprised how many of these character ROMs I have, actually. I've got about 5 here. I've got more of these than anything else. It shows they fail a lot less, so that one's alright as well, look. And this was the last one, I think. And then we just got the faulty one to test from the C64C board. Yeah, that is right. It's just my blooming TV again. It's surprising the reset takes an awful lot longer on a bread bin than it does on that C64C. But then again, on the C64C, they cut corners, didn't they? They just used that capacitor, resistor and a diode or something. Anyway, yeah, so that's all 4 of those spares good. And this is the one that gave us garbage on the C64C. Should see the same here. Yeah, there we go, exactly the same. There we go, marked fixed 2022. It wasn't so much of a repair as more of a complete build, wasn't it? Because there was so much missing. The ROMs here, the character ROM was bogged. That ROM was balked, that chip was balked, that was balked, I think, unless it didn't have an NEC one, in which case that 4066 from the previous 64C was balked. The colour RAM was balked, the PLA was balked, and obviously the other chips were not on here. So that chip was good. It's like, literally bought it with that chip. Oh, and this one. Oh, and that one. So 3 chips. It had 3 7.4 series on it that were okay. So what would cause that? I actually think an overvoltage. I actually think the 5-volt rail must have gone, 7, 8, 9 volts at some point and been left on for a period of time. Ultimately, that's what I think the issue was. But yeah, the PLA is definitely balked. I've swapped it back for the other one just to prove. Got the original black screen back. So yeah, and I've got a spare one of these, as you saw me use earlier, just to test things and stuff. It was interesting, we discovered the colour RAM problem whilst we had no, the machine wasn't running, just by virtue of high impedance connection. If you get high impedance connection around something, it always needs further investigation. That was the colour RAM there, so yeah, it's even got a new colour RAM. So thank you very much for watching. If you'd like to support the channel, please see Ko-fi and Patreon links down below. You could also click the join button to join, become a YouTube member. There's like 8 or so early access videos on there. There'll be the occasional exclusive and stuff. And there's the first 4 parts of me moving into this environment, working on the desk here. It's all pretty dark and fuzzy, but it's just there as a bonus. I do hope you found the video interesting. Thanks for watching. Catch you in the next video.